Kia ora, Year 12 and 13. This is an excellence question from last year's integration paper, and it's about water pumping out of a tank. It's not too bad as long as you remember how important similar shapes and similar triangles are to a lot of harder integration questions. And we've got a really good diagram that's going to help us with that idea. So we're given a diagram showing us an inverted right pyramid, meaning it's got a right angle if you stick a line through the middle. Right, so what does that mean? It means if you think about the sort of centre of the pyramid base, you've got a right angle triangle in here. Okay, and the pyramid's initially filled up with water to a depth of 1 metre. What else is important? Well, the height of the whole thing is 1.5 metres, and importantly, this width here is 0.9. We're going to need that in about 30 seconds. So we're given a formula for the energy needed to pump water out of a tank of height h, and this is it here. What we have to do is to go through and figure out the parameters that we have to chuck in to solve the problem. So the initial depth of water in the tank we're given as 1 metre, so d is equal to 1. D is equal to 1. H is my variable. That's how deep the water is at any instant. And then we have to figure out when the depth is h, what is the surface area of the water. Now you can see that the surface area will be a square. So what we have to ask is that when, how wide will it be at any particular level. So you can see that here it's a ratio of 0.9 to 1.5. And so you can figure out that if we were full up at 1 metre, that we'd have to have that same ratio. So 9 over 15 works out to be 3/5 or 0.6. So when we're at 1 metre here, we'll be at 0.6 metres here. But just more generally, that lets us figure out the area of the surface area anywhere will be linked with height like this. So we've got the width is equal to 0.6 times the height. And so the surface area, because it's a square, is going to be just that squared. I think that's the hardest part of this whole question. So the surface area is given to us by 0.36h squared. That's that bit done. This is easy because this big H is the tank height. So big H is 1.5. So we've got big H, we've got my surface area bit done. H is the variable, and this H minus D is also easy to find. So we can start substituting in. We've got E is equal to 9,800. The top limit is H, so it's 1.5, and the bottom limit is H minus D, which is 1.5 minus 1. And now we've got H minus H, 1.5 minus H, times 0.36 H squared dH. We can start to clean that up. We can pull this constant out to the front, which gives us 3,528. My limits are between 1.5 and 0.5, and I'm just going to expand this bit out here. So we get 1.5 H squared minus H cubed. So it's a really easy integration problem now. Okay, so we have 3,528 times this integral, so it will be 1.5 over 3 h cubed minus 1/4 h to the power of 4, evaluated at the usual limits. So that's a little bit messy on your calculator, but just be careful with it. It is easy to muck it up. Let's leave the 3,528 sitting there. I'm going to have 0.5 times 1.5 cubed minus 0.25 times 1.5 to the power of 4. Take away 0.5 times 0.5 cubed, which obviously I could simplify, but I don't need to, minus 0.25 times 0.5 to the power of 4. Right, so when I substituted all of those values in, I got this. I'm writing this in just in case there's someone who's sitting there going, oh, I've mucked something up on my calculator. So don't round it too hard. And get really good at using your calculator for problems like this, because We don't want to be doing this with fractions or anything crazy, right? So we've got this minus 0. Trying to read my handwriting. I think it's 0.0156. I'm sure someone will leave me a comment if it's wrong anyway. But then I put all that in, and I ended up with 1,323, and I think the unit was joules. We'll just go back and check. Yeah, that is. So the energy in joules is done. So that's it. You can check the schedule for that to make sure I've got it right. But just again, I think you'll find if you're doing lots of practice as you lead up to the end of year, this similar shape stuff here comes up so many times in integration problems. So it's just something to have your eye out for. And then there'll usually be some kind of information that lets you work out what that link is. And in here it was to spot that you had a relationship of 1.5 and 0.9. Let me know if this helps, and if you've got any more questions that you want done, just leave me a comment or send me an email. Thanks for watching.